Hello friends, welcome back once again. This is Nagraj SK, Lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belagavi. So in this video, I'm going to continue with lecture number 45 and 46 and end up uh, with this unit, that is unit number 5, Decrease and Conquer. So I'm going to complete this unit with these two lecturers, and I'm going to cover here the topics like DAX and topological sorting of this decrease and conquer. So I'll be briefing you about what are DAX, what is topological sorting, how it works, and so the topological sorting. Topological sorting is a process of assigning a linear ordering to the vertices of a directed graph. If there is an edge from vertex I to vertex j, then I appears before j in the linear ordering. It is a direct implementation of decrease and conquer method. That is, we discuss a very important problem for direct graphs here with a variety of applications involving requisite restricted tasks. Before we pose this problem, though, let us review a few basic facts about directed graphs themselves. A directed graph or digraph for short is a graph with direction specified for all its edges. The adjacency matrix and adjacency lists are still two principal means of representing a digraph. There are only two notable differences between undirected and directed graphs in representing them. That is, the first one, the adjacency matrix of a directed graph does not have to be symmetric, and at the second one, an edge in a directed graph has just one, not two, corresponding nodes in the digraph's adjacency lists. The depth first search and breadth first search are principal traversal algorithms for traversing digraphs as well, but the structure of corresponding forests can be more complex than for undirected graphs. Thus, even for simple example, I'll be showing that example in further PPTs. That is, the depth first search forest exhibits all four types of edges possible in a DFS forest of a directed graph. That is, tree edges and back edges, which are from vertices to their ancestors, and forward edges, that is from vertices to their descendants in the tree other than their children, and cross edges, which are none of the aforementioned types. And also we have to note that a back edge in a DFS forest of a directed graph can connect a vertex to its parent. Whether or not it is the case, the presence of a back edge indicates that the digraph has a directed cycle. Then what do you mean by a directed cycle, right? A directed cycle in a digraph is a sequence of three or more of its vertices that starts and ends with the same vertex, and in which every vertex is connected to its immediate predecessor by an edge directed from the predecessor to its successor. And edge directions lead to new before that conversely, if a DFS forest of a digraph has no edges, the digraph is a DAG. That is nothing but, DAG is nothing but, if a DFS forest of a digraph has no back edges, the digraph is nothing but a DAG, an acronym for directed acyclic graph. And edge directions lead to new questions about digraphs that are either meaningless or trivial for undirected graphs. So we'll move to the this is about the basic things. Before going for this topological sorting and all, we have to understand what is traversal of the graphs, digraphs, right? So here the next thing is DAX. A DAG is nothing but a directed acyclic graph, that is, a directed graph with no directed cycles. Arise in modeling many problems that involve prerequisite constraints, construction projects, or document version control. Vertices of a DAG can be linearly ordered so that for every edge its starting vertex is listed before its ending vertex, that is topological sorting. Being a DAG is also a necessary condition for topological sorting to be possible. So here I am showing a DAG, that is this thing. The first diagram shows that this one shows that a DAG, that is A is pointing to B is pointing to D, then A is again pointing to D, and A is pointing to C, then C is pointing to D. That is, there should not be a cycle. See, if you check this, if you see this diagram, it is a cyclic graph, so it is not a DAG. That is, it is pointing first A to B, then B to D, then D to C, then C to A again. It is pointing, it is creating a cycle here. So this is not a DAG. DAG is nothing but directed, but it should be a cyclic graph. So this is about DAGs. Then steps of topological sorting are, the steps to be followed in topological sorting algorithm are: from a given graph, find vertex with no incoming edges, delete it along with all the edges outing from it. If there are more than one such vertices, then break the tie randomly. Note the vertices that are deleted. All these recorded all these recorded or noted vertices give topological sorted list. These are the steps of topological sorting. What is that? From a given digraph, find vertex with no incoming edges, delete it along with all edges outing from it. If there are more than one such vertices, then break the tie randomly. Note the vertices that are deleted. We have to keep a record of that. All these recorded or noted vertices give topological sorted list. We have to verify that. That is about steps of topological sorting. Then for example, we have here uh, 1, 2, 3, 4, 5, 6, 7 vertices in the digraph. So 1 is pointing to 2 is pointing to 4 as well as 5, and 1 is pointing to 3, right? So we are following here that topological sorting method, and we are getting this topological sorting order, this one. That is, first we are going to delete the, at the very first we are going to delete, in the first step we are going to delete this first one that we are noted. Then second one, in the second step we are deleting this, so we noted that. Then 3, 4, 5, 6, 7, then finally we will be getting this topological ordering. So this is about example of the topological sorting. And now we have topological sorting, that is DFS based algorithm. So what this DFS based algorithm says, right? DFS based algorithm for topological sorting: perform DFS traversal, noting the order vertices are popped off the traversal stack. Reverse order solves topological sorting problem, and back edges encountered, not a DAG. This is topological sorting, that is, it says it will be performing a DFS traversal, noting the order vertices are popped off the traversal stack. Reverse order solves topological sorting problem, and back edges encountered, yes, then it is not a DAG. This example shows that. A, B, E, F, and again it is pointing to this. So it is not a it is a DAG, directed acyclic graph. Then next we have topological sorting source removal algorithm. What is source removal algorithm, right? Usually this source removal algorithm repeatedly identify and remove a source, a vertex with no incoming edges. What it does, identify and remove a source, that is a vertex with no incoming edges and all the edges incident to it until either no vertex is left, then problem is solved, or there is no source among remaining vertices, that is not a DAG. So it will be identifying and remove a source, that is a vertex with no incoming edge. First we have to identify this. First we have to identify this vertex which is having no incoming edge, that we are going to delete. This is not having incoming edges, that means this will go, this will go. Then later this is not having, this will be not having, again this will be not having, then we will be removing this, we'll be deleting this, and then it will be not having no incoming edges, right? So then finally we are deleting this. Similarly for other vertices also. And we are uh, noting that, recording that, which is the order of that, which is the order in which order we are deleting them. That is what topological sorting with source removal algorithm. Then let us summarize what we discussed so far. We discussed the following things: that introduction of topological sorting, then DAGs, what are DAGs, what are topological, how topological sorting works, then topological sorting algorithm and analysis, and finally examples for DAGs and topological sorting. So this is all about this topological sorting and tags. If you are having any doubts in this, please do ask your queries. And thanks for watching.